Okay, so I can start the video. So I'm gonna go straight to question 2. So I'll skip around a few. So let me write the question, and it says the absolute value of something, right? I don't know the value. This is an unknown value as of now. I don't know what V is. So the absolute value of something is going to be less than 54. So first thing I'd like you to think of all the numbers that could represent. So absolute value of what numbers would be less than 50, less or equal to 54. Now, so let's think about 55. Let's go one higher than 55. Obviously, that is not going to make this true because the absolute value of 55 is 55, and 55 is not less than 54. So 55 is out. So obviously, and let me draw my number line here. Okay, so we're not solving anything, we're just establishing this. So 54, so what if I take the absolute value of 54? Would that be less or equal to 54? Yes, it would. So I know on this side, put a little circle over here, and this stands for 54. Above 54, it's not going to work, right? So it has to be 54. In this case, it can be 54. So anything going down, 53 would work, 52, 51, 50, 50, 49, 48, all those. 33, let's see, the absolute value of 33 is 33. And is that less or equal to 54? Yes, 3. So far, all these numbers are working, and it would fulfill the requirement that it should be less or equal to 54. So work, work, work. And then now start thinking about negatives. I mean, so let's just assume that this is a 0. Negative 1, absolute value of negative 1 is 1, which is less than 54. That works. Negative 2, negative 3, and negative 4. And hopefully you'll see that all these numbers will work up to this point. And this point is negative 54. So if I take the absolute value of negative 54, that's going to give you 54. And is that less or equal to 54? Well, it's definitely not less, but it's definitely equal. So it meets the other condition, right? Now, let me go one over here to the left and take the absolute value of negative 55. The absolute value of negative 55 would be 55, and that is definitely not less or equal to 54. So it stops right there. So, and I can shade it because the absolute value of negative 54 is 54, and that'd be okay, right? So this is going to be shaded. Now, all these numbers, starting from negative 54, including negative 54, going all the way to 54, and including positive 54, which therefore I'm going to shade, make this condition true. So as long as I put, now put a question mark here, any of these numbers from here all the way to here, it would meet that requirement, right? So what does it mean? It means that the absolute value has to be before, so the absolute value has to be between these two numbers. So let's do that. Let's put that there. So the absolute value, whatever number I put in here inside these parallel brackets over here, right, inside this, has to be between these two numbers. And to be between these two numbers, this guy right here has to be here. Whatever value this turns out to be has to be between 54, negative 54, and 54. And that's how I work out that number. So this is my setup. Knowing this will help me set up my inequality. Okay, so now I want to isolate my variable just like you would isolate an inequality or an equation. And to do that, I would divide this guy by negative 9. And I'm going to divide this by negative 9 and divide this guy by negative 9. Now it's 3 parts, so you divide everybody by negative 9. And now, like we discussed yesterday, if you divide by a negative or negative, divide or multiply by a negative number, you're going to, the sign has to flip over to the other side. Negative 9 is going to be positive 1, and positive 1 times v is just going to give me v. 54 divided by 9 is negative 6, and negative 54, blah, 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 and negative 9 is going to be 6. So 6 is greater than v, which is going to be greater than negative 6. So let me represent this part, my answer, right? Because I need, so v is going to be any number that is less than 6 and is greater than negative 6. So the representation of that, and again, you draw a number line, and v is here. So on one hand you have 6, on the other hand you have negative 6, and v, let's put a circle here, and again it says v can be greater than negative 6 or it can be equal to negative 6, so we can shade this. v can be less than -6 or equal to -6. And we can shade this too. So in this case, v is going to fall between these two numbers. So v can be any number between -6 and 6. So now again, if you would like to try it, so pick a number from -6 all the way to 6. Let's start with 0. If you choose 0, you're going to get -9 times 0. And that should have an absolute value of less than -54. -9 times 0 is 0. And if you take the absolute value of 0, it's just 0. And 0 is definitely less than 54. Let's pick another number. Let's pick 5, right? 5. Let's pick 5 and see if... let's pick 5 as a value for v, and let's see if it works. So if I have -9 and I multiply it by 5, right, that should be, the absolute value should be less or equal to 54. -9 times 5 is -45, right? And now I take the absolute value, and the absolute value of -45 is 45. So is that less or equal to 54? Yes, it is. So again, any value between -6 and 6, and v is going to be any value from -6 to 6, and that's going to hold this statement true. So that says if I take the absolute value of any number that is multiplied, any number between -6 and 6, and multiply it by -9, it's going to be less or equal to 54. Okay. Let's do 4. Let's not do 4. 4 is almost the same. So let's do 6. So 6 has this particular setting and has x plus 5 equals is less than 9. So again, I want you to, in a way, let me put a question mark there. All right, so think of all the numbers that I can put in here that I can take the absolute value and will be equal to 9, less than 9. Well, it can't be 9 because 9 is not less than 9, but it can't be 8.99, right, or 99999. It could be 8, it could be 7, it could be 6, it could be 5, it could be 4, 3, 2, 1, and any number in between those whole numbers. It could be 0, it could be 0.5, it could be 0.08, negative, by the way. And I'll keep going. -1, that will work. -2, -3, -4, -5, -6, -7, -8, and -8.99999. I think I can take the absolute value of that, and that's also going to be less than 9. But if I take the absolute value of -9, it's not going to work because the absolute value of -9 is 9, and 9 is not less than 9 in this case. So I have like a little idea of what my values can be. So this absolute value of my mystery number has to be a number between 9 and -9, not including 9. So when I put a 0 here, I put a circle on top there, and do this. This represents all the numbers that I can take the absolute value of, and that's going to be less than 9. So for example, 8, I'm not talking about the value of 8, so let's go back to this over here. Absolute value of 8 is 8, and 8 is less than 9. Let's pick -7. -7, absolute value of -7 is 7, that's less than 9. So all these numbers work. Right, so what does that tell you? This says that in order for this to be true, the absolute value has to be, right, this value, x plus 5, has to be two things. It has to be greater than -9, right? So numbers that are greater than -9, and x plus 5, this value over here, whatever this value is, also has to be less than 9. So my x plus 5 is going to be a number between -9 and 9, my x, right? And a easier way to write that, it's writing like this. So x plus 5, right? Whatever value this is, whatever absolute value I'm taking, has to be a number between, it's going to be less than 9, and on this side, it's going to be greater than -9. So whatever this value here has to be between those two numbers. So let's find out what that number, or what value of x it's going to be. So in this case, I'm going to subtract 5 here, and subtract 5 here. If I do that, these two go adios, x comes down, 9 minus 5 is 4, and negative 9 minus 5 is negative 14. So the value of my variable x can be any number between negative 14 all the way to 4. That's the value of my variable. Okay, so if you want to check, let me erase some of this part over here. I wanted to check just to see if, if I'm actually telling you the truth. Pick a value for x. Now we have so many numbers we can pick of, anything between negative 14 and 4, not including negative 14 and 4. So let's pick 0. So if I take 0 as a value of x and I substitute it over here, I'm going to get 0 plus 5 less than 9. 0 plus 5 is 5, and the absolute 5, I'll do it one step. 0 plus 5 is 5. I haven't taken the absolute value yet. Now I can take the absolute value of 5, which is 5, and is that less than 9? Yes, it is. Let me pick another number. I don't know. I picked 0, so let me pick one that's over here. Let me pick 3 for x. So if I pick 3 for x, I'm going to get 3 plus 5 less than 9. 3 plus 5 is 8 less than 9. And if I take the absolute value of 8, I'm going to get 8. And is 8 less than 9? Yes, it is. So far, it's working. So let me pick a negative number one. Let me pick negative 12, which is between these two numbers. So negative 12, so I'm going to get negative 12 plus 5 is less than 9. Negative 12 plus 5 is negative 7, less than 9. And the absolute value of negative 7 is 7. And is that less than 9? Yes, it is. So, again, the values of my x, my variable x, can be any number between negative 14 and 4. Okay? And that's the answer here. That's it. Let me pick a different one. So this was all less than. Let me pick number 10. Number 10 is greater than. Okay, so greater than is a little bit different, right? So x plus 4, absolute value has to be greater or equal to 74. So now, again, I want you to first think about all the numbers. So again, let me make a question mark here. The absolute value of something that I don't know is going to be greater than 74. So what numbers would fulfill this? Well, let me put 74. Is the absolute value of 74 greater or equal to 74? The absolute value of 74 is 74, so that would work. What about 73? If I take the absolute value of 73, it's going to be 73. Would that work? No, it won't. So if I put a 74 over here, already I know that this number, 73, is not going to work, but 74 works. And let me put 75 for a second. Absolute value of 75 is 75, and is that greater than 74? Yes, it is. So numbers on this side, on the right side, 74, greater than 74, or even equal. Right? So any number that is equal to 74 or greater than 74 would, and if you take the absolute value of that number, would definitely be greater or equal to 74. So on this side, that number and every single number after that, greater than 74, would also work. Now, 73 doesn't work, 72 won't work, 71, 70, so I'm, again, focus here. 69 doesn't work, 68, 67, all these numbers don't work because if you take the absolute value of those numbers, it's going to be less. Now 0 doesn't work, negative 1, and then keep going. And if you notice, nothing's going to work until you reach negative 74. Once you reach negative 74, if you take the absolute value of negative 74, the absolute value of negative 74 is 74, and that works. And so in this case, let's put the circle there to represent negative 74. And 74 works, and then we can shade that, pick negative 75. The absolute value of negative 75 is 75, and 75 is greater or equal to 74. So you can tell now that numbers on this side also are going to start work. So this is a little bit different than the one before because those were less than. This is greater than. So I know that the absolute value, this guy here, 7x plus 4, has to be two things. Let's start with, so 7x plus 4 has to be two things. It has to be less than 74, less or equal to negative 74, or 7x plus 4, right, has to be, and you can tell here, has to be greater or equal to 74. There's two things. It's either going to be less than or greater than. So every number greater than 74 works. Every number less than 74 works, right? Remember, negatives, the more left you go, the smaller they get. So now you get to solve two inequalities. And we're going to do -4 here, -4 here. Disco out Dios, 70x, and then 7x, and you're going to get negative 77. Divide both sides by 7. And x is going to be less or equal to 11. On this side, again, I'm going to do -4, -4. And this is going to be 0. I'm going to get 7x has to be greater than 70. Divide by 7, divide by 7, x is greater or equal to 10. So let's graph that. So because I want, these represents the x values that are going to make this inequality true. So let me find my eraser. Let me erase this part over here. So let me draw a number line. Okay, so that's going to represent the x values that I'm going to substitute in here to make this inequality true. So on one hand, I have 10, and I need any number that is equal to 10 or greater, and that's represented by that. Any number that starts at 10 and goes to the right, right? So x can be any number on that side. And then on the other side, all right, well, this is -11, by the way. That's where my mistake is. And then on the other side, I have -11 over here. So x can be -11 and any number that is less. So I'm going to point to the right. So I can pick any number that's less than -11 or any number greater than 10, and it will make this true. So again, do a check. It's not going to hurt you to do a check. So let's pick a number greater than 10, 20. So I'm picking a number greater than 10. I'm going to pick 20, and I'm going to substitute in here. So I'm going to get 7 times 20 plus 4 greater or equal to 74. So let's do inside. 7 times 20 is 140. 140 plus 4 is 144. And you can already see that's going to be true. The absolute value of 144 is 144, and that is definitely greater than 74. So numbers over here are working. So let's pick on numbers that are -11 or less. Again, I'm gonna pick. Let me pick -12 at this time. So, (7) times -12. Something's wrong already. What am I doing wrong? 7 times -12. Absolutely. Oh, no, it's not wrong. 7 times -12 plus 4 greater or equal to 74. Let's see if that's true. Inside, 7 times -12 is, I don't know, 1484, right? -84, and -84 plus 4 is -80. And if I take the absolute value of -80, it's going to give me 80, and it's 80 greater than 74? Yes, it is. So numbers to the left of -11 also aren't working. Okay. Let's pick another one. Hopefully you're doing the evens, because that's what I'm doing. Let me pick one you haven't seen yet. Let me do 14, and then I'm going to do 18. So 14 says, well, it's not that complicated, but plus 7 is greater than 16. So before you start thinking of what numbers I can, or imagine the number line to see what the absolute value of what numbers are greater than 16, I want to simplify this inequality. Okay, so I'm not going to change anything, right? Because I am going to do the same operation to both sides, so I'm going to keep the balance here. So it's -7 over here, -7. These two 7 go bye-bye. I'm left with absolute value of 7 is greater than 9. This one's not that difficult. So if I put number 9, In order for the absolute value of a number to be greater than 9, it obviously has to be greater than 9. So numbers 9, not 9, because 9 is not going to work, but 9.1 is going to work, 9.00001 would work. So any number right after that, I point it that way. So those numbers work. The other number that don't work, 8 won't work, 7, 6, 5, 4, 3, 2, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 8 doesn't work, but negative 9 also doesn't work. So anything very close to, really close to negative 9 will not work, but right after that, negative 9.1, negative 9.2, if you take the absolute value of those numbers, they're going to be greater than 9. So we have this pointing that way. So numbers to that way, and this one is, we actually already solved it because it's just that simple. So the values of x that's going to make this true is going to be x is greater than 9 or x is less than negative 9. Okay, this one is really simple actually. I'm gonna pick on 18 then. Clear. 18. So I have x minus 4 absolute value over 5 less or equal to 2. Now, I want to get rid of that 5, and to get rid of that 5 is division, right? So the opposite of division is multiplication. So think about clearing the fractions in a way. You can think about that. I'm going to multiply this side by 5, right? I'll multiply this side by 5. I multiply this side by 5. This and this simplifies, and I'm left with x minus 4. Less or equal to 2 times 5 is 10. Now I want you to think about, and again, what values, what numbers can I take the absolute value of and have it be less or equal to 10? So would 10 work? Yes. Would 9 work? Yes. Would 11 work? No, it wasn't. So let me start drawing this number line. So my 10, if I put 10 in here, and I'm going to put 10 over here actually. Would the absolute value of 10 be less or equal to 10? Yes, it will. So because it can be equal, we're going to shade it. And just to confirm, if I take a value that is to the right of 10, like 11, the absolute value of 11 is 11, and that's definitely not less or equal to 10. So numbers on this side don't work. So I'm already going this way. Okay, 10 works, 9, 8, 7, 6, 5, 4, 3, 2, 1, negative 1, negative 2, negative 3, negative 5, negative 9, even negative 10, up to negative 10. If I put the absolute value of negative 10, it's 10, and that's definitely less or equal to 10, so that's going to work. But the absolute value of negative 11, if I put negative 11 over here, take the absolute value, I'm going to get positive 11, and that's definitely not less or equal to 10. So numbers on this, so let me put a circle. So all these numbers work. You reach negative 10, it also works, but then you have to stop, because anything after negative 10, it's not going to work. So I know that this value here, okay, has to be between negative 10 and 10. So, and that tells me how to set up my equation. So I need to set this up so that this value, the absolute value of this unknown value, has to be between negative 10 and 10. So negative 10 has to be less than this value, and this value has to be less than 10. So this x minus 4 has to be between negative 10 and 10 in order to work. Set it up. Plus 4, plus 4, plus 4. Oops. And I'm going to get 14, I'm going to get negative 6, and I'm going to get x. So the value of x that I can replace here has to be any number between negative 6 and 14. So let me draw a number line for that. So this represents the values of x that I can substitute here. And it's going to be negative 6, 14. So any number, and I'm going to shade because negative 6 is also part of my solution. So my numbers are restricted to these two numbers between negative 6 and 14 inclusive. So if you want to check, just to see that, tell you that I'm telling you the truth, right? I'm going to check over here. Let's pick negative 6. If I take negative 6, and I do negative 6 minus 4, less or equal to 10. Negative 6 minus 4 is negative 10. And negative 10, or absolute value of negative 10, is definitely less or equal to 10. So that value checks. So pick another value in here. And again, you don't have to pick 2, 3, 4 values, but I'm just trying it out. Well, let's pick 8. 8 somewhere around here. So if I substitute 8, okay, state that x equals 8. Let's see if that works. So I replace this with 8. So 8 minus 4 is less or equal to 10. 8 minus 4 is 4. Less or equal to 10. The absolute value of 4 is 4. And that is definitely equal to 10. So the values of x that I can substitute in here are these numbers right here. Any number that are between negative 6 going all the way to 14 inclusive. Okay. I don't know if hopefully this helps. I'll do 22. So 22, I have 8 plus 4v minus 7 greater or equal to 17. So again, let's get rid of that 8 first. So minus 8 on the other side. Those two go adios. I'm left over with the absolute value of 4v minus 7 has to be greater or equal to 17 minus 8 is 9. So ignore this for a second and think of all the numbers that you can take the absolute value of that's going to be greater than 9. So definitely has to be like 10, 11, 12. So if I draw a number line and think of all the numbers that I can take the absolute value of. Can I take the absolute value? Let's start with 9, right? Smallest. 9. If I take the absolute value of 9, it is 9. And 9 is definitely greater or equal to 9. So this works. 9 works. I'll put 9 here. If I take the absolute value of 8, will that be greater or equal to 9? No, it's not. So already I know that I'm not pointing this way, but I'm pointing that way. 11. The absolute value of 11, is it greater or equal to 9? Yes. So I know that on this side, that works. 8 won't work. 7, 6, 5, 4, 3, 2, negative 1, negative 2, blah, blah, blah. Negative 9. If I get to negative 9, if I take the absolute value of negative 9, it's going to give me 9. And is 9 greater or equal to 9? Yes, it is. So this also works. So let me shade it in because we have an equal here, right? And I know every number between negative 9 and 9 does not work, but what about negative 10? It's the absolute value of negative 10, if I put it in here, greater or equal to 9. The absolute value of negative 10 is 10, and 10 is greater than 9. So again, we can clearly tell that these numbers, every single number to the left of negative 9 will also work. So what I do know is that this absolute value, this value over here has to be less than 9, or it could be greater than 9. So let's set up our equation, our inequality. So 4v minus 7 has to be less than negative 9. Less or equal, by the way. Less or equal to negative 9. And this says that 4v minus 7 has to be greater or equal to 9. So let's do this two-step inequality. So I'm going to do plus 7, plus 7. Again, I get 4v less or equal to negative 2. Divide by 4. Divide by 4. And v is less or equal, and that's going to be a half. Let me get this right, negative 0.5. On this side, plus 7, plus 7. I get 16. 4v comes down because this goes out. Divide by 4, divide by 4. And v has to be greater or equal. And 16 divided by 4 is just 4. So I'm going to draw a number line to represent that for the value of v. So v can be any number, and on this side, any number that, here's my 4, any number that is equal to 4 or greater to 4. And or v can be any number, and let me put this negative 0.5 here, right? Any number that is less, so it can be 0.5 and any number that's less than that. So here's an or. So either numbers on this side or numbers on that side will make this inequality true. So check let me pick something from the right side. Let me pick something over here. Let's just pick 4. Okay, let's just pick 4. So if I pick v, if I say v equals 4, inside I'm going to get 4 times 4 minus 7, and that hopefully is greater or equal to 9. 4 times 4 is 16. 16 minus 7 is, I have no idea, 16 minus 7 is 9. And if I take the absolute value of 9, it's just 9. And is 9 greater or equal to 9? Yes, it is. So that works. Again, you can keep plugging in numbers, as many as you want, just to make sure. 5, 6, 7, pick 100, 1,000, numbers on the right side of 4. Just to make sure, I want to pick numbers on the left side, and let's make v to the left of negative 0.5 is negative 2. Let's make v negative 2. So it's going to be 4 times negative 2 minus 7. That should be greater or equal to 9. 4 times negative 2 is negative 8, which I then have to subtract negative 7. And that supposedly is greater or equal to 9. Negative 8 minus 7 is negative 15. And the absolute value of negative 15 is 15. And is 15 greater or equal to 9? Yes, it is. So values to the left or equal to 0.5 also work. So the answer to this question would be v has to be less or equal to 0.5, any number to the left or equal to 0.5, or v can be also numbers greater or equal to 4. Okay, so I have 2 choices. I'm hoping this helped. Okay, that's it.